In this video, we'll be talking about the process of osmosis. Now, let's start off by defining what osmosis is. So osmosis is a passive process. So we're not talking about a form of active transport here. So it's a passive process, and this is where a solvent, now in biological systems, it's usually water, moves across a membrane, a semi-permeable membrane. And one way to think of it is water moves from an area where there's a low concentration of solute, right? Remember, water is the solvent, the solute. Now there's another way to think of it, is that there's more water molecules in that area. So water moves from an area with more water molecules across a membrane to an area with a higher concentration of solute, or the other way to think of it is less water molecules. So let's have a quick look at that. So let's just draw a container. So here's a container, and then let's put in a semi-permeable membrane. So here's a semi-permeable membrane in the middle. And what we're saying that we're looking at basically a mixture of stuff. So what we have are basically water molecules. So we have water molecules. Okay. And water molecules over here. And then I have that solute that is in there. Now, what I'm trying to represent is on the right side here that there's more of this solute. So let's say that these green dots represent, let's say glucose, okay? So you can see, here I have the blue water molecules, and I do have some glucose, not a super high concentration of glucose here. And over here I have water molecules, okay? And I have a lot more glucose, the solute. And what we're saying is, remember that this membrane is semi-permeable, right? So there is the ability for water to move across. And really, what is osmosis? Osmosis is that here, where there's a lot of water, very little solute. Over here, there's water with a lot of solute. Water molecules will move to the area where there's a lot of the solute. So we're going to see movement of water across here. And that's the basis of osmosis. Now, over time, if you think about it, what's going to happen is, so let's just make this represent water here. Okay. So we have water here. We have water here with a lot of glucose within it. Okay, and what we've seen is that water molecules will move across. They're going to be moving across. Let me change that. So water molecules are going to be moving across. So what's going to happen is, as water is moving across, of course, I'm going to start to lose water here, and I'm going to start to gain water here. And over time, we'll see that we will see that the amount of water will go down here because it's moving over. And of course, because it's moving over to the right-hand side, the water will be picked up and it'll be added. So part of this movement of osmosis will move more water over to this side. Okay, and let's go back to the original slide we're looking at. So let's remind ourselves. So osmosis, it's a passive process. The solvent, which is usually water, moves across a membrane. And we should also point out, typically we're looking at a semi-permeable membrane, which means not everything can cross. And the way I like to think of it is water moves from an area where there is more water molecules proportionally across a membrane to an area where there is less water molecules when I look at the total percentage of molecules on either side. So, how can water move across the plasma membrane? Well, there's two ways. Water can actually pass through these channel proteins, and here's a very important phrase: aquaporins. Aqua for water, porins for pores. And this is a primary route for osmosis of water when we're looking at membranes. But there's a second way. Small amounts of water can pass through the phospholipid bilayer directly. So we see that illustrated here. We can see here's a water molecule using one of these aquaporins to cross. And you can see here that the amount of solute is lesser concentration, so there is less solute up here. And here you can see there is much more solute, so I have a higher concentration of solute here. So remember, it's not the solutes that are moving, it's the water molecules. So the water's moving to basic. I also like to think of it as water's moving in to help dilute the amount of solutes. That's another way I think about it. All right, so what they're trying to show you here is what we just talked about, is that we have a membrane that is not permeable to the glucose. Okay, sorry, there's the glucose. But you can see that very little glucose compared to over here where there's a lot of glucose. So proportionally, there's more water molecules here. And as we said, osmosis is about moving from an area where there's a lot of water molecules proportionally to areas where there's not as much water. Now, of course, as we said earlier, as water moves across, there's going to be a net loss of water here, and there's going to be a gain of water here. So the volume will change on this side. But you notice that the net result is that we sort of end up with sort of an equal concentration of the solutes within the solvents. Now, here's two phrases that are very important. Osmotic pressure. This is the actual driving force that's exerted by the solute molecules and causing water molecules to move until equilibrium is reached. Okay. And at the point, pressure is applied to the solution to prevent water from moving into it by osmosis. So let's go back here to this diagram. Now, one thing I want to point out is that, yeah, water can move this way, but some water can move this way, right, through random motion, etc. And what we're saying is, even when we hit this point where we've sort of diluted out the solutes, there's still going to be some movement of water from here and water there. But the amount of water moving in either direction is equal. So it's not that there's no movement of water, but it's equal. So the net effect is I'm not going to have any more water moving at a certain point. And that gets us back here, right? Is that the driving force is exerted by solute molecules until equilibrium is reached. There's another term here, which is hydrostatic pressure. Let's highlight that. Hydrostatic pressure. And this is the force water exerts on the walls of its container. Now, this term is going to become very important next semester when we start talking about blood dynamics. Like in capillaries, there's a hydrostatic force that has a role in moving fluid from inside a capillary to the local tissue. And we'll talk much more about that when we get to the appropriate chapter. Okay, so I just want to do that introduction to it and sort of define what is osmosis, talk a little bit about how the water moves, talk a little bit about solute versus solvent and who's actually moving, talk a bit about osmotic pressure, and introduce the concept of hydrostatic pressure. And we're going to leave it there for now.